Hello everyone, welcome back. This lesson, the lesson we're starting today, is the last part of unit number 3, and this is called applied problems, word problems in other words, where you may have to use what you've learned about conic sections to actually be able to answer the problem that's being given. This begins on page 37 in your notes. I've got a few problems, a few select problems picked out that I'm going to do here on pages 37, 38, 39. The ones that we don't cover, I'm going to assign for you to do for practice, for your for homework. We're going to start with question number 1 right here. And this question actually has a little bit of a background here in Doha. Let's read it very carefully and see what it says. The swords that cross over Grand Hamad Street approximate a parabola. And sure enough, if you look in the diagram here, I think I've actually passed that landmark a few times. Here's your ground. We're going to assume the ground is right on the bottom of this parabola. Think of that as your x-axis. Put it that way. It approximates a parabola. If the base of the arch, okay, where the street is 65 meters wide, and if the maximum height, well, that must be our vertex, right there at the very top. If the maximum height is 35 meters, formulate an equation to give the height at any point along the arch. So the height, of course, would be from the ground, and that's why we put the ground, we insist that the ground is actually the x-axis. And we'll put the y-axis right in the center of our parabola as well, right where that maximum height occurs. Now, of course, if I drew it over here like this, watch carefully. What if we said, here's our parabola, there's those swords, okay? So from one end to the other, right from there to there, remember that's 65 meters. If we assume this is the x-axis and this is the y-axis, then that means this point right there, that is your origin, that's 0, 0, okay? Right at the very middle of the base. It also tells us that the maximum height is 35 meters, and that, ladies and gentlemen, tells me that the vertex is at 0 and 35. And that's an important point for a parabola, isn't it? But that's where the vertex occurs. Now, what else? Well, the fact that we've got the vertex and the fact that it opens downward, people, that's a lot of information right there. That is a lot of information, isn't it? In fact, we could almost write down the equation just given that. But I think we're going to need another point somewhere on that parabola, and it has to do with the width here on the bottom. Now, if we know that the vertex is right in the middle of the base, 0, 0, or sorry, not the vertex, the origin, 0, 0 is right in the middle of the base, and if we know that that base is 65 meters wide, we can divide that by 2 and get our two x-intercepts, all right, the two coordinates where that parabola hits the x-axis. And in fact, what you would get is 32.5 and 0. That's one of them. The other one over on the other side, of course, I don't know if I can squeeze that in there, would be negative 32.5 and 0. All right, so that's what we have for the second x-intercept. Now, what we're going to do is we're going to write this equation. We have to get the equation of the parabola, you see? So let me see. The fact that it's opening downward, that tells me that the x part is squared. The x is squared. The vertex is 0 and 35. So it's going to be x minus 0. Well, you don't need the minus 0 in that case. So it's just going to be x squared on the left-hand side equals now don't forget there's a sort of a coefficient. There's some kind of a number. We were calling it 4p, I know, and you can still leave it 4p if you like, or you can just put a there if you want. I don't think we're really going to find out p in this problem right here. And then the linear term is going to be y minus 35. Okay? Now you can clearly see you've got a lot of that equation already. The only thing is this. What in the world is that going to be? How do we figure out that negative 4p? Because we have to get that down to some number. And p is not the height, by the way. That is not p. All right? You don't know what p is. You have no way of getting what p is. Well, I shouldn't say that, but you can't exactly find out what p is easily. So here's what you do. Let's take some point that's on that parabola. We did something like this when we looked at circles. If you can find a point that's on the parabola, not the vertex, but some other point, if you put that x and y coordinate into this equation, everybody, you should be able to calculate 4p. And not necessarily just p, but you want to get 4p. So leave the 4 and the p together, treat it as a single variable. And I'll tell you what we should plug in. What about that x-intercept right there? All right, put that in. So I'll put the 32.5 in for x. I'll put the 0 in for y, because remember, that point is on my parabola. It should make my equation true, shouldn't it? So you're going to end up with 32.5 squared. All right, that's what I put in for x, is equal to. Now leave the 4p together. You never, ever, ever have to separate that. The y coordinate is 0. Take away 35. All right. Now remember, I'm going to leave the 4 and the p together. It's not necessary to work out just p by itself. Okay, 32.5 squared. Let me see. What will I get? What will I get on my calculator? Let me grab my calculator and see what I get. 32.5 squared. I get 1056.25. 1056.25 is equal to, now right here, this little piece, well folks, that's just negative 35. So I'm going to put the negative 35 in front of 4p. Don't multiply that out. It's not really necessary to multiply that out. But watch what happens now when I divide both sides by negative 35. I think I'm going to get my value of 4p. And it's 4p I want, because 4p is what's going to go into my my parabola. You see the equation of my parabola. So I'll take that 1056.25. I'll divide that by negative 35. If you wanted to, you could change that into a fraction. If your calculators can do fractions, you can certainly do that. If you leave it as a decimal, though, here's what you're going to get. I get approximately negative 30.178. So I'm going to call that 1/8. Now that is 4p. I suppose I could go ahead now and find p, no problem. But why? Why would you do that when in your equation 4p is what's required, and that is 4p. So here's your final answer. Watch this carefully. X squared is equal to, you've got negative 30.18. And like I say, you could have written that as a fraction if you wanted to. And then in brackets, y subtract 35. And that equation, ladies and gentlemen, that is the equation for the height of that parabola at any point. So if you were stood, for example, let me look at my diagram. What if you were stood, I don't know. What if you were stood right there? See what I'm drawing? I'm drawing in the actual picture. What if that was 10 meters from the center and you wanted to get how high that arch was above your head if you were 10 meters from the center? Well, by golly, you'd put 10 in there, right? Because that would be an x value of 10. If this is 0, then 10 meters away from that would be an x value of 10. 20 meters away, you'd plug in 20 and you'd get your height. And that's the way these things work. So, all right, that's that one done. Now let's go down and look at number 2. Now number 2, I got a little bit of a warning for you. Number 2 can be a little bit tricky. Some of it might involve math that hopefully you've seen before, but it's quite possible you may not have seen it for a while. Let's see what we've got. Let's read the question carefully. It says, a rose garden has 2 intersecting circular paths. All right, so I'm assuming that those 2 circles, they're like an aerial view of some paths that you're looking at, with a fountain at the center of the longer path. All right, so I guess that's my fountain right there. Not focus, that's F for fountain. These are 2 circles, you see, right? Circles don't have a focus. All right, so the path can be represented by the equations x squared plus y squared minus 20x plus 75 equals 0. Okay, well, that's one of the circles. I don't know which one though, or do we? And what's the other equation? Let's see, there's one equation. The other one is x squared plus y squared equals 100. Now I do know one thing. I do know this circle here has its center at 0, 0. Now this one, I don't know where the center is because actually that's in general form, isn't it? Okay, but I do know the center of the this circle is 0, 0. All distances are in meters. Now what? Look at this. Look at this. That fountain, that little dot right in the middle, that's supposed to be the origin. That is supposed to be the origin. So in other words, watch what I'm going to add to this diagram. My x-axis is going to kind of come like this, right through where that fountain is, cut through both circles like that. That is supposed to be my x-axis, right there. And of course, if that fountain is at the origin, then I guess my y-axis kind of cuts down something like that right there. So there's my x-axis and there's my y-axis. And now I can tell which equation belongs to which circle. Because, you see this one again? That one right there. That has its center at 0, 0. And the fountain is at 0, 0, so look at that. That's that circle. And this other one up here, the one with the bigger equation, the general equation, that must be that circle right there. All right. Now, also, not only do I know the fountain is at 0, 0, but there's something else I know as well. X squared plus y squared equals 100. Look, there's my radius squared. So that means that the radius is 10 all the way around here. 10, 10. All of this piece right there, that's 10. The radius is 10 everywhere in that larger circle. Now the smaller circle, what's the radius, I wonder? Because we're going to need that to answer part A. Look at what part A is saying. I'm going to write that first equation down here. X squared plus y squared equals 100. Because I think in just a moment, I'm going to need to scroll down and I won't be able to see those. So watch what I'm going to do, everyone. Now the other one was what? X squared plus y squared minus 20x plus 75 equals 0. There's my second one. That's supposed to be a 0 there. All right. Now, I'll tell you what. If I want to get the radius of that circle right there, the smaller one, I'm going to need to convert that back into standard form. So remember how we did that now. X squared minus 20x. I put my x squared and x together. All right. Leave a little space. There is no y term there, so I just need to write plus y squared. And then I bring my 75 over to the other side, and I get negative 75. So what do I add there inside that set of brackets? Well, a half of 20 is 10. 10 squared, I add 100, look. And I really did add 100 this time. There's no number in front. There's no negative in front. So I also add 100 to the right side as well. So here's what you're going to end up with. X minus, okay, half, what's the square root of 100? How about 10? X minus 10 squared. And then plus y squared. And that is going to equal 25. Look at that. So that smaller circle, that point right there, I wish I had a nice stylus. I'd be able to put it in really tiny. That point is actually 10, comma 0. Right there. That's the center, right? You can see that from the coordinates here. That's the center of that smaller circle. And also I can see that the radius, r, is the square root of 25, which in our case is 5. So that distance there is 5. That distance there is 5. All right, the radius of the smaller circle is 5. And actually, if you look carefully at that diagram now, look very carefully at that, we can answer part A, and I'm pretty sure we can answer part B as well. Because part A says, what is the closest that the shorter path, now remember that's the smaller circle, both of those circles are paths. What is the closest that the shorter path gets to the fountain? Well, I think at this point right there, all right, if you were walking around this small circle, this was your path, then right there is when you'd be closest to the fountain. Now, if the large radius is 10 and the small radius is 5 right there, ladies and gentlemen, that means that the closest you're going to get to that fountain is 5 meters. That's the closest you're going to get. Part B says, what's the furthest that shorter path gets to the fountain? And again, the shorter path is the smaller circle. And I'm pretty sure if you were to walk around that small circle like it was a path at this point, furthest away, that's when you'd be farthest away from the origin, right, or from where the fountain is located. Well, that would be 5, and the big radius is 10, so 10 and 5. Ladies and gentlemen, that's 15 meters. That is 15 meters. Now, I wish I could say that Part C was just as nice, because let's see what Part C says. Part C says, how far apart are the intersection points of the two paths? So let's come up here and let's look at that diagram again. Now I'm going to clear some of this away so that we don't have a whole lot of clutter there. Just clear some of this stuff away. All right, so let's see now. What are they asking us to find now? What are they asking for? Well, the intersection points of the two paths, let me point out where they are. Here's one, right there. And here's the other, right there. Now they're asking how far apart those 2 points are. And it's not just 5 plus 5 or something as easy as that. In fact, you've got to find out where those 2 circles intersect. And that is something called, that's actually a system of equations, but it's not even linear equations. That's a system of I guess, general second-degree equations. How would you solve that? Well, you solve them kind of like you solved a system of linear equations. You look for substitution or perhaps elimination, something along those lines. But like it's not that trivial. Let me show you what you should do. I'm going to take x squared plus y squared equals 100. Let me write that down here because I'm kind of running out of room. X squared plus y squared equals 100. Now remember, that's the equation of the larger circle, isn't it? I'm also going to write down the equation of the smaller circle, which is x minus 10 squared. All right, let me write that over here. X minus 10 squared. All right, x minus 10 squared. And what else do we have? What else do we have? I wonder, should I write it down in that form? No, you know what? I'm going to write it down in the other form. I'm going to write it down in the other form. Let me erase that. And there's a reason for that, because you see, I'm going to get x squared by itself in that first equation. So I want x squared in the second equation. So x squared plus y squared. Not trivial, is it? X squared plus y squared. And what else do we have? We have minus 20x plus 75. Minus 20x plus 75 equals 0. Now, what I'm going to show you, you may not have seen something like this before, but it is solving a system of equations. I'm going to take this first equation right there, and I'm looking at the second equation. I notice that there's x's in it and there's y's in it. I'm going to try to get rid of the y's. So what should I going to do? I'm going to write this as x squared equals 100 minus y squared. All right, see what I did? Now, if I were to substitute in the second equation for x squared, look at what I'd get. I'd get 100 minus y squared in brackets, and then plus y squared. Now, you see what happens? The y squareds vanish, don't they? Minus 20x plus 75 is equal to 0. So let me see, what will that give me? Well, if I remove the brackets, I'm just going to have 100 minus y squared plus y squared. They're going to disappear. So I'm going to have 100 minus 20x plus 75 is equal to 0. Now, if I get that x by itself, what I'll end up with is negative 20x is equal to, now 175. Bring that to the other side and I get minus 175. And ladies and gentlemen, you divide both sides by 20, and here's what you're going to get. 8.75. Now, 8.75. Come back up to your graph, up to this equation. Now, remember, that 8.75 is your x value. That's the point right there, approximately. And just above that and just below that, that's where the graph actually intersects. The two graphs, the two circles intersect. You need the y values. All right, so this is 8.75 and something. and down below it's 8.75 and something. But you need the y's. Because whatever the y values are, that y value there, that y value there, you're basically going to have to like kind of find the difference between them. All right, how far up does that go and how far down does that go? Not very simple, is it? It's not trivial. Now, what would you do to get your where would you plug that x to get your y? Well, why not plug it back in there? That one looks like maybe the simplest equation. So 8.75 squared is equal to 100 minus, that's a 100, minus y squared. So let me get my calculator out. Let me see what we get. 8.75 squared. 8.75 squared is 76.5625. All right. But when I bring my 100 over, it's going to become a subtract. So if I subtract 100 from that, you're actually going to get something like negative 23.4375. That's equal to, and now this side, don't forget, the right side is actually negative y squared. So, of course, you're going to divide both sides by negative 1. They both become plus. You then take the square root of that positive 23.4375. I told you it wasn't trivial, didn't I? And you know what I get approximately? Plus and minus, because remember, it's squared. You're going to get two values here. 4.84. You know what? This is not a trivial question. I'll guarantee you that. So the y value is 4.84 up above. And down below it's negative. I'll put it down below. Negative 4.84. See that? So if that's the y value, that's this height. And down below the axes, that's this height. So basically, 4.84, you double that. So the height, or how far apart they are, the points are 2 times 4.84, which is what? 4.84 doubled, 9.68 meters apart. I know what you're thinking. I hope they don't ask this on a test. Well, I'm not saying you will. I'm not saying you're going to see one like that on a test, but the fact that it's in the booklet, the fact that it's in the textbook, you could see something like it. It's quite possible. All right, so make sure you look that one over very carefully. That one was not trivial. That was definitely not trivial. And let me see, we're a little over 20 minutes now into this video. I tell you what, I'm going to stop this video and I'm going to come back and do maybe number 3 on the next page. Number 3, maybe number 4, and I think maybe number 6 on the top of the other page. All right? So I'll stop this video and I'll start another one now in just a moment. Okay? So I'll see you in just a little while. Bye-bye.